Welcome back. I'm Rob Martin, the Astro Meathead. In this episode, I'll be talking about the software I use for planning and framing my astrophotos. These apps allow me to plan my shots, lay out framing, and find true north, and align my mount. Then I use them to locate the stars nearest to what I want to shoot and star hop my way there. Then we'll go into some of the software I use to process my photo sessions into a cohesive image. First, we'll get into my favorite piece of planning software, Telescopius. This is a free app, but won't be found on the App Store. It's found on their website, telescopius.com. I use Android, but it's available for iOS as well. I have this app on several different devices, including phones, laptops, and tablets, under the same login. I definitely recommend signing up for the free account, as it allows you to save equipment and viewing lists for future reference. So, here's what you get. Type in a deep sky object you're interested in. They do give some suggestions of what's in the sky based on your location and date if you aren't quite sure what to look for yet. Let's start with something I love to shoot. It's easy to find and has a couple of awesome reference markers right in the middle, the Pelican Nebula. Located in the constellation Cygnus, it's part of a huge area of nebulosity right next to the spectacular North American Nebula. It's a great target for beginners, as you will see in a moment. Scrolling down, let's see what this app tells us. This chart tells us the location, when and where in the night sky this nebula will be. The red line you see here represents when it's visible from east to west. The white dot shows when it's at its highest point in the sky directly on the meridian, or north-south center at your location. You'll also see here transit north at 73 degrees and 11:42 p.m. Here's how to read this. 11:42 p.m. is the time the nebula will be at its highest point in the night sky along the meridian. Imagine a giant protractor bisecting the sky from east to west, with your east and west horizons being the zeros. At 90 degrees, or straight up, in a line from north to south, is the meridian at your location. If you take that same protractor visual and turn it on a north-south axis along the meridian, with the horizon to the north being zero, the transit north at 73 degrees starts to make sense. At 11:42 tonight, the Pelican Nebula will be at your meridian at 73 degrees above the northern horizon. Thinking about how the stars move in an arc across the sky, this will help you to figure out where it is at any given time throughout the night. Another thing to notice about this chart is the pair of yellow lines to each side. These represent the twilight hours of evening and morning, with the black area between them representing nighttime. The white line here represents the rise and set of the moon according to this chart. From my location tonight, I'll be able to photograph the Pelican Nebula from about 9:30 p.m. until about 1 a.m. with little to no interference from the moon. After 1 a.m., the moon has the potential to interfere with my session via light pollution if other factors like cloud cover or topography reflect moonlight towards my camera. With a light pollution filter, I should actually be able to image all night. Scrolling down a bit more, this information will become important later in our journey, but I'm going to skip it for now, as it's not absolutely necessary for us for what we're doing. So let's jump down to the telescope simulator. I love this. In my opinion, this is one of the most time-saving features of the app. If you sign up for a free account here, you'll be able to save your camera, lenses, telescopes, whatever, and combine them to see what you can frame up with your gear. Let's take a look. For camera here, I have my trusty Canon 80D selected. It's an APS-C-sized DSLR. All of the info you see here, sensor size and pixel count, is all available with a quick Google search. Onto the lenses, I have the 50 Canon f1.8 selected, and the framing is a bit wide. Let's see what else I have. You might have a zoom lens or a high power prime or fixed power lens. Let's choose my Sigma 75-300 listed here and see what we get zoomed all the way out. Still a bit small. How about zoomed all the way in at 300? That's pretty good. Using my camera and this lens, I know that this is the approximate framing I'll get without turning my camera's orientation on the mount. This app, keep in mind, is not showing what you will get with any particular gear, but gives you a representation of what should show up in your framing based on your sensor and lens combination. It's up to us to make it pretty. The next app we'll be looking at is another free app, this time in the Play Store, called Stellarium. The free version does have some restrictions that can be a bit annoying, but the premium version is very affordable and highly recommended. We'll use the free version here to get us started. This app helps put into view what Telescopius showed us in the charted location of our nebula. Let's take a look. Tapping the screen gives us a search bar, and here's one thing that absolutely drives me crazy. Typing in common names for most nebulae will take you right to them, but for the Pelican, you'll need the catalog number, which can easily be found on Google or Telescopius. So typing in IC 5070 gets you, wait for it, the Pelican Nebula. Go figure. So you get a bit of info and history, more technical information, and most importantly, a map. Many of these stars, the brighter ones at least, represented here by size, are visible with the naked eye from dark-ish skies. I live near a medium-sized town, so I have moderate light pollution. Unless you live in a larger city with crazy light pollution, you'll probably be able to see Vega and Deneb. Satyr and Epsilon Cygni are visible to me all night as well in the summer months. We can see that the brightest nearby star is Deneb. Just to the east are these two bright stars we saw earlier in Telescopius that actually bracket the nebula. So all we have to do now is find that in our camera's view screen and collect a few hours worth of pictures. You can use your phone as a locator by pointing it straight up and then finding your target by moving around until your phone points the way. Now you have a starting reference point to frame up your camera. Next, I'm going to briefly hit on two other free apps for your phone or tablet that are fairly important to the process. The first is a compass app. The one I use, this is the one I use, as it uses GPS and your address to precisely locate your phone and give you accurate results. I'm not going to show the screen because of that. It will correct for geographical north rather than magnetic north. Geographical north is where you want to align your equipment. We'll discuss this in our setup video later. A polar clock is next. This is one of them that I use. The other one is built in the app that controls my star tracking mount when it wants to work. This one always works, and it's free with no ads that I've seen. This app is used for polar alignment of the tracking mount and is essential for getting everything lined up just right. The last two pieces of software I'm going to look at this time around are Deep Sky Stacker and New Image Manipulation Program. DSS takes all of the photos you just took, as well as calibration frames, and performs a series of actions designed to combine them all into a single image with a better signal-to-noise ratio and reduced digital noise, ready for processing. Lastly, we'll take that combined image and drop it into GIMP, where I can show you how to do a simple stretch of the histogram or light map to reveal what hopefully will resemble the Pelican Nebula. In the next video, we'll be going over the setup for our gear and using these apps to find, frame, and photograph a deep sky object. Until then, clear skies and heavy weights.